So if you've been listening to these slides in order, you know that I've talked recently about just single cells, just single thunderstorm cells, and kind of approached it along the lines of something we call an air mass thunderstorm. Could be a sort of this single kind of gentle thunderstorm cell. I'm going to talk about something called supercells, but I want to revisit that just ordinary thunderstorm cells can bring all sorts of havoc. But supercell thunderstorms actually go through the same three stages, the cumulus, mature, and dissipating stage as regular thunderstorm cells, but they are they have a great deal of instability associated with them. You might have heard when we're having hail or tornadoes, meteorologists talk about supercells. And so supercells last longer than a typical thunderstorm cell. They have a great deal, like I mentioned, the vertical instability. They have a large, in general, amount of warm, moist air. They can last a long time. The thing about supercell thunderstorm cells, now remember we use the word TS to abbreviate thunderstorm cells or thunderstorms, is that supercells can, and we'll talk more about this later when we talk about tornadoes, can develop what we call a mesocyclone in their core. Kind of like a pineapple core, that's what a mesocyclone is. And do you remember that, and you're going to see on the next slide, we talked about at the mature stage, thunderstorm cell has both an updraft and a downdraft. And associated with the downdraft, if this is my cumulonimbus cloud, associated with the downdraft, of course, we have precipitation. The mesocyclone you're going to see on the next slide is actually, I mentioned a pineapple core. It's kind of like a big old blobby rotation that is in the core of the thunderstorm cell. And as I've kind of drawn it here, can you see where it can wrap some of the updraft with some of the downdraft? And basically, we get a wraparound situation. A mesocyclone creates that, and this rotation actually then is the rotation that's associated with what's this? This is a twister. And I think we probably talked about something called a wall cloud, and it will drop down from, as I understand it, your mesocyclone. So if the meteorologists say we have our thunderstorm is composed of, it's got supercells embedded in it, this is what it's talking about, a supercell thunderstorm. And like the bottom here says, we can get our tornadoes from supercells. So this isn't an ordinary cell, this is a supercell thunderstorm. In a minute I'm going to kind of show you what this would look like from the air. But it has characteristics like we've talked about. I mean, it's got the overshooting tops. It would look really crisp as it's developing. You see both, let's see, I'm looking for the updraft, but it looks like the updraft here is kind of in red, maybe? No. Nah. The downdraft clearly is this blue line. Associated with the downdraft, we would have our precipitation. But this is a mesocyclone. And this is, the mesocyclone was in the middle of the supercell thunderstorm. This is what a supercell might look like from in orbit about the Earth. So what you're looking at, these are the overshooting tops. Okay, and it is possible, we're going to talk here later soon about systems of thunderstorms, and it's possible to get a group of thunderstorms, either a squall line or probably more likely what we call a complex of thunderstorms, a mesoscale convective complex, that the thunderstorms are actually supercell. So these would be your supercell TSs. And this is what it might look like on the ground as it's approaching you. Now remember, whether you're going to see the overshooting top or whether you're going to see the anvil or that sort of thing kind of depends upon your perspective. If the cumulonimbus cloud is right on you, it's not happening. You can't get perspective. So clearly, I don't know if you can see this from your vantage point, but that is a tornado.